Okay, today's class is about the parametric inference. So we're trying to infer some parameters, so we don't know what's the population's distribution. So we're trying to find out what is the population distribution in terms of what will be the mean or what will be the standard deviation. So that is what we call the parameters. So can we infer those populations parameters using data? That's the parametric inference. So statistics is divided into the two big branches, so theoretical statistics and the applied statistics. And also the applied statistics also can be divided into the two. So one is a descriptive statistics, and then the other one is a inferential statistics. So descriptive statistics is when we get a bunch of numbers, bunch of data, then we can tell what is the mean, what is the shape of distribution, what is the standard deviation. Yeah, we can describe that data. Okay, so that data can be a population, but we just find out what could be the best way to describe this data set. That's the descriptive data. Inferential is a little different because we collect the data from the population. We don't get a whole population data, but we're trying to find out how can we find out what is the parameter for the population. But we don't have a population data, but we use a sample data. So using sample data, trying to infer the population information. So why infer? Because we cannot have a whole population data. So this is how we use the sample data instead of census. So census means here the census means is if we collected the data from population. So if you are interested in the height of the student at university, so we can collect everybody's height. We measure everybody. Then that data we call is a census because we examine everybody there. So my data set is the population data. But maybe university we can do that, but if you are trying to find out what will be the height for everybody, it's gonna be really expensive. It takes a long time to measure everybody's height, right? So that's why we use a sample. Sample means we, instead of measuring everybody, we just randomly selected a smaller number of sample, and then we analyze that data. But our ultimate goal is to find out what is the population statistics. But what we have is only the sample data. So using sample data, can we infer? Yeah, of course we cannot exactly know what will be the population, but that's why we call it inference. Can we infer what was the population parameters? So analyzing sample, yeah, we infer the property of the population. So measure of the sample, we call this is the statistics, and then measure of population, this is the parameters. What it means is that if you calculated the mean of the sample data, that's the statistics. Because using statistics, we find out. Statistics also has two different meaning. One meaning is it's a branch of the academic area, right? That's a statistics, and then the other one is actually the number we can get from using statistics, like mean, standard deviation, and so on. Measure of population, we can get a real mean. So why we don't call it statistics is that's the true number, true average of the population. So that's not a statistics, that is the parameter what we call. Parametric model is when we create the statistical parametric model, it's a set of distribution that can be parameterized what does it mean, the parameterize is? For example, normal distribution, we can tell exactly what kind of distribution is if we know the two parameters, mean and standard deviation. So that's one parameter model. There is the exponential distribution has a one parameter. You need to know the lambda, which is the one parameter, but normal distribution has a two parameters. So if we know one or two or sometimes it's three parameter model, if I know that those one or two, the number of parameter, that number of the number I know, then I can describe exactly what is the distribution. That's a parametric model. So we will talk about the mainly the parametric model because the non-parametric model is kind of a little difficult. So non-parametric model is the distribution cannot be expressed using the finite number of parameters. So it's gonna be a little different approach and then a little difficult. So that's why we will focus on the parametric model in this course. So we know the what type of the distribution it was, but I don't know what is the parameter. So I know my population follows exponential, but I don't know what is mean. Or I know this is a normal distribution, but I don't know what is mean and what is standard deviation. So once we get a sample, then can we infer what was our population's mean and population standard deviation? Of course, directly we can calculate what is the sample mean and sample this standard deviation, but can we infer the population mean and population standard deviation using the sample data? Okay, so if x following the normal distribution with the mean mu and the variance is a sigma square, so then parameter is mu and sigma, which is the mean and standard deviation. So if we try to estimate mu, which is the mean, then mu is parameter of interest. Okay, so because I want to know what is the mu, what is the mean, then mean is the parameter of interest because I'm trying to find out mean. However, to find out the whole distribution shape, then we also need to know the sigma because the normal distribution has a two parameter model. If you know the whole distribution, you have to have you need to know the standard deviation also. So this kind of the parameter we call is a nuisance parameter. So I'm not interested in that parameters, but that is the one of the parameter of our distribution. Okay, and then parameter of interest is not always mean and standard deviation. Yeah, most of cases it's a mean standard deviation because once you know mean and standard deviation, you can tell everything, every other things. So that's why it's mostly mean and standard deviation. However, the parameter of interest can be some complicated function of mean and standard deviation. So maybe you are not interested in the mean itself. Maybe you are interested in something complicated things, but still we can infer the parameter of the population if it's a function of mu and standard deviation. So estimator of the population mean. So we try, of course, the here mean is the just example, but how can we estimate our population mean using data? So if we sample n number of samples, so we collect the n number of samples from population. So I don't know everybody's data, but we collected the n number of data as a sample. It is impossible to know the exact mean of population from the sample, right? That's just randomly sample. It's just small part of our population. So it's impossible to know, but we can estimate. At least we can infer what would it be, right? Using sample data. So what do? So if you collected this n number of data, then what would you do to infer the mean of population? Yeah, you're gonna calculate the sample mean, right? And then using the sample mean, and you estimate that would be our population mean too. That's a pretty straightforward common sense, but why? Why is that a right way? Can you say just sample mean is the same as a population mean? Is it? Yeah, intuitively that's true, but why? That's what we are trying to find out.